Hello everyone. Today we are going through some important questions of real numbers. First question, if two positive integers p and q can be expressed as p is equal to ab square and q is equal to a cube b, where a, b being prime numbers, a and b are prime numbers, find the LCM of p and q. LCM of p and q. Okay, here two numbers p is equal to a b square, a into b square, q is equal to a cube into b. So here we have to find the LCM. See how to find the LCM? LCM is nothing but product of greatest power of all the factors. Okay, all the factors involved in this number. So here what are the factors involved in this number p and q? A and b. Factors are a and b. Okay, so here greatest power of a. So LCM of PQ, that is equal to, what is the greatest power of A? 3, right? So A cube into, okay, A cube into greatest power of B is 2, that is B square. So here LCM of P and Q is A cube B square. So what about HCF? So HCF is nothing but product of smallest power of common factors. Okay, smallest power of common factors involved in this number. See here, common factors are A and B. Okay, and product of smallest power of common factors. So smallest power of A is 1. So here HCF of PQ is smallest power of A is 1. So A into, here smallest power of B is 1, therefore B. Okay. So HCF of P and Q is A into B. Look at the second question. If HCF of 253 and 440 is equal to 11, and LCM of 253 and 440 is equal to 253 into R. Find the value of R. We have a formula, that is relation between HCF and LCM and the numbers, right? So here HCF of 253 and 440, what are the numbers? 253 and 440. So HCF into LCM of 253 and 440, that is equal to 253 into 440, product of given numbers. Okay, then it is given, right? HCF and LCM are given. HCF is 11 into LCM is 253 into R, that is equal to 253 into 440. Here 253 cancelled, then R is equal to 440 divided by 11, that is 40. Therefore, value of R is 40. Check whether 12 raised to n can end with the digit 0 or 5 for any natural number n. See here we have to check whether the number 12 raised to n can end with the digit 0 or 5 or any other number. N is natural number. Okay. And we know that any number ends with the digit 0 is divisible by both 2 and 5. Okay. And any number ends with the digit 5 is divisible by 5. Okay. Not 2. Okay. Only 5. Not only 5, any other numbers except 2. Okay. So here, now we have to check whether 12 raised to n is divisible by both 2 and 5. If it is, then we can say this number can end with the digit 0. Okay. And if 12 raised to n is divisible by 5, then we can say this number can end with the digit 5. Okay. So here, first of all, let's write any number ends with the digit 0 0 is divisible by both 2 and 5. Okay, both 2 and 5. And any number ends with the digit 5 is divisible by 5. Okay. Now, here let's write this number, given number 12 raised to n can be written as, see here we have to write this number 12 as a product of prime factors. Okay. That is 12 can be written as 3 into 4. 4 can be written as 2 square, right? 3 into 2 square whole raised to n. That is 3 raised to n into 2 raised to 2n. Right? So here only the prime factors 2 and 3. Okay? Prime factors are 2 and 3. There is no 5. So by the fundamental theorem of arithmetic, there is no other prime factors in the factorization of 12 raised to n. That means 5 is not a factor of 12 raised to n. Okay? So by the theorem, 5 is not a factor of 12 raised to n. Okay? Now see here, any number ends with the digit 0 is divisible by both 2 and 5. Okay? And any number ends with the digit 5 is divisible by 5. But there is no 5 here. That means there is no 5 means 5 is not a factor of 12 raised to n. That means 12 raised to n is not divisible by 5. Okay? That is 12 raised to n is not divisible by 5. Thus, given number 12 raised to n cannot end with the digit 0 or 5. Okay? 12 raised to n cannot end with the digits 0 or 5. Next question is, find the least number that is divisible by all the numbers from 1 to 10. See, what is the least number divisible by? That is nothing but least common multiple. Right? Least number divisible by all the numbers from 1 to 10. 1 and 10 are included. Okay? So here we have to find LCM of numbers 1 to 10. Right? Least common multiple, that is LCM. Okay? LCM of 1 to 10. Okay? So first of all, how to find the LCM of 1 to 10? Let's write the prime factors of all the numbers. Okay? So 1 can be written as, okay, no need to write 1. Okay? 2 can be written as 2 into 1. 3 into 1. 4, 2 into 2. We have to write the prime factors of all the numbers, okay, from 1 to 10. So 5 can be written as 5 into 1. 6, 3 into 2. 7 into 1. 8 can be written as 2 cube, right? 2 into 2 into 2. And 9 is 3 square. 10 is 2 into 5. Okay. Now, how to write the LCM? LCM is, that is product of each prime factors. So that is greatest power of each prime factors involved in this number. Okay. Now, what are the prime factors involved in these numbers? 2, 3, 5, 7. Right? 2, 3, 5, 7. Now, let's check the power. Okay. So, first of all, here LCM of numbers 1 to 10 is equal to first prime number 2. What is the power of 2? That is greatest power of 2. 3. Right? So 2q. Product of greatest power of each prime factors involved in this number. Okay. 2q. Okay. That is prime factor. Prime factors are 2, 3, 5 and 7. Okay. And greatest power of 2 is 3. Therefore 2q. Into next prime factor 3. What is the greatest power of 3? 3 square, right? So 3 square into next prime factor is 5. Power of 5 is 1. Therefore 5. Okay. Into next prime factor is 7. Power is 1. So greatest power is 1. Therefore 7. That is equal to 8 into 9 into 5 into 7. 40 into 63. That is 0, 12, 25. Okay. So 2520 is the LCM of numbers 1 to 10. That is least number that is divisible by all the numbers from 1 to 10 is 2520. Explain whether the following number is prime or composite number. 3 into 5 into 13 into 46 plus 23. So let's check whether this number is composite or not. If it is not a composite number, then it is prime. Okay. Means here if this number has factors other than 1 and itself, then it is a composite number. Okay. So here, and composite number can be written as product of prime factors. So let's simplify this one. Here see there are two terms and 23 is common. In both the terms 23 is common, right? So 46 is 23 into 2. So here this can be written as, take 23 outside. Okay. So 3 into 5 into 30 into 2 plus 1. Okay. We have taken 23 outside. So 23 into, here 3 into 5, 15. 15 into 26 plus 1. That is 23 into 15 into 26 is 390 plus 1 391. That is equal to 23 into 391 can be written as 23 into 17. Okay. So here this number has factors 23 and 17. That is, this number has factors other than 1 and itself. Therefore, this number is a composite number. Okay. So, given number has factors other than 1 and itself. Okay. This number has prime factors other than 1 and itself. Therefore, given number is a composite number. A circular field has a circumference of 360 km. 3 cyclists start together and can cycle 48 km, 60 km and 72 km a day round the field. When will they meet again? See here, a circular field of circumference 360 km and there are 3 cyclists. Cyclist 1 can cycle 48 km per day and cyclist 2 can cycle 60 km per day and third cyclist can cycle 72 km per day. So here we have to find when will they meet again. Means after starting, when is their meet? Okay, when they will meet. So here, first of all, let's find how many days they will take for one round. Means for 360 km. Okay, that is for one round, how many days? So here, see, first cyclist takes travel 48 kilometer, right, per day. So here how many days? That is 360 divided by 48. Okay, so here we will find how many days they will take for one round, that is for 360 kilometer. So 360 divided by 48, that is 7.5 days. So first cyclist takes 7.5 days to travel 360 kilometer for one round, and second cyclist 360 divided by 60 that is equal to 6 days. Okay, so second cyclist takes 6 days to travel 360 kilometer. And what about third one? 360 divided by 72, that is equal to 5 days. Okay, see here first cyclist takes 7.5, second cyclist 6 days, third cyclist 5 days to travel 360 kilometer. See here we have to find the when will they meet again, means after starting point when they will meet. Okay, that is after how many days they will meet. See here for one round they will take 7.5 days, 6 days, 5 days. Okay, so here we will find the multiple, common multiple. Okay, that when they will meet, that is the common multiple. Okay, common multiple of these numbers. Not only common multiple, least common multiple. Why? Because after starting next, what is their next meet? When is their next meet? Okay, so here least common multiple of these numbers, that is 7.5, 6, 5. That is least common multiple means LCM. So here we have to find LCM of 7.5, 6, 5. That is the common multiple, least common multiple. Okay, when they will meet, they meet means common multiple. So what is their next meet? So here least common multiple. Okay, so how to find least common multiple of 7.5, 6, 5? See here, see how to find the least common multiple of decimal numbers. See here, you just take LCM of, make it multiply by 10. Okay, so that it will become an integer, right? That is 75. 75. And here also you have to multiply by 10. 60, 50. Okay, now find the LCM of these numbers. 75, that is 3, 25, 5, 5, 7. Okay, then after that 60, 3, 20, 2, 10, 5, 2. Okay, then 50, 2, 25, 5, 5. So here 75 can be written as 5 square into 3. 60 can be written as 2 square into 3 into 5. And 50 can be written as 5 square into 2. Now find the LCM. Okay, so here what are the factors? We have to write each factors. So what are the factors involved in this number? 2, 3, 5, right? So here LCM is LCM of 75, 60, 50, that is equal to 2, the power of 2, greatest power of 2 is 2 square, okay, 2 square into 3 into 5 square, okay, that is equal to 4 into 25, 100, 100 into 3, 300. Okay, we have got LCM of 75, 60, 50 is 300. Here we need to find the LCM of 7.5, 6, 5. Here we have multiplied by 10, right? So next is, you just divided by 10, okay? That is LCM of 7.5, 6, 5 is equal to 300 divided by 10, that is 30. So what is 30? 30 days. So after 30 days, they will meet again.